Hi everyone, and welcome back to another Daily Crave coding video. This time we're going to keep doing Punctual. I'm doing the standalone Punctual because it has the newer version of Punctual, well, actually it just got updated today in Estuary, but the standalone version was already on the more recent the more recent version, which means it's going to match the docs better, and I'm going to not confuse myself as often. Okay, so we're going to kind of pick up where we left off last time. I'm just going to go grab that same moth URL because I like it. Okay, and we're going to start playing from here, and we're going to first start by showing the stuff that we had talked about before, and then sort of moving on from there. So if I want to, save a texture or something, I can just give it a descriptive name. We can call it moth. And so now, instead of the texture command, I would say this. And then that's it, right? Like, so image doesn't actually take other arguments. And so if I were to just send moth to video, what we would get is that. Okay, neat, cool, great. So what you do now is set fxy. And okay, and so this time the coordinate arguments come first. And if I just put in fx and fy, that's just going to be the identity transformation. And it won't change anything. Okay. Now, if I were to do fx, we're going to get the columns of color like we had before. And then if we do something like to take something to a power, and we'll see the same distortion we had before. Okay, so that's what these set functions are for. There's also one that's just fx. So I could just do that. I think that would work. Yep. And it would leave fy unmapped, and similarly there's a fy. Okay. Yeah. So I can also just map those. So cool. All right. And there's other ones like spin, which honestly, I have no idea what spin will do if I give it something dynamic like f of fx. What I was going to say is that spin, we could do like, can rotate the image, right? And then we do negative 0.5, it'll be back that way. If we do, negative 1, it'll be upside down. Positive 1 will also be upside down. Okay, good. So it is describing the whole circle. It's identifying negative 1 and 1. Cool. That's great. Now, what the what the heck happens if I do this? Okay. It actually is rotating it. It is calculating the new position on the per pixel basis. Awesome. That's actually super great. That's super great because that means there's a whole lot of just dumb stuff we'll be able to do. I muted for a second, so that means that's my 3 years in running dry cough. I have to make the jokes about it, right? Otherwise I'm just impossibly self-conscious. Okay, and alright, so you can see this bends up over here and then down over here because squaring means we're getting rid of the fact that it's negative over here and positive over here. Okay, so that's cool. So it's like giving sort of a consistent turn, except that the squaring means it's all distorted. because now things closer to 0 become much closer to 0, and things, yeah, okay. That is super great. Now, what if we do something like fx times fy? What now? Why does that cancel out? Okay. That's a little more what I expected. Yeah, okay. Oh, does that not work? Okay. So yeah, we are just doing terrible things to this. Okay, let's figure out what other functions exist that we can kind of mess with. Oh, right. So I remember when there was a talk last year, which is how I first really learned about Punctual, and in the talk there was other interesting kind of functions. So let's do let me see, what do I want to do? Let's multiply this by dist of 0, 0, so like the distance from the origin. Okay, so that's cool. That means it gets darker as it gets closer to the center point, because then this is closer to 0. So, if we want to make things iris out to the edges, we could do this. I think should work. Yeah, so it's brighter, closer to center, darker. And then we can put an exponent to exaggerate the effect further. And okay, I need to find out, does the exponent properly handle if you have fractional exponents? It does, okay, which means, in principle, oh my goodness. Sneezing is a crime in the pandemic. But, okay, so now what we can do is we can use the range function, which, and then do it for the sine of 2. Okay, so this should get a pulsing spotlight, I think, since the exponent can handle fractions. Boom, 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 boom. Okay, very good, very powerful. And then what we haven't talked about is that there is sound. And what's cool, what I think Punctual is doing well, and this is actually something I was confused about earlier, is that it's kind of treating things in the audio domain and video domain as kind of being the same stuff. So what we can do is something kind of like, well, here. Okay. If we do this, we'll hear a tone, right? Okay, that's a little loud. But what we can also do is, let me see. So we can't use like distance or anything, but oh God, what if we did this? What if we actually had Oh, this is gonna be weird because we're doing is distorting the shape by the same exponent. But if we do it like this, then we should be able to hear that it will line up with the video pulsing. Oof. That was more unpleasant than I wanted, but that's okay. I was hoping for it to be a little here. Let's instead let's make it like a lower pitch anyway, and then we can kind of mess with the oh, right. It's not it's not going to do putting in the exponent like that isn't going to have things change the rate at which you would normally want them to. Right. I was thinking about in terms of like more like a multiplication of waves, because really what I was thinking of was something more like really on some level what I was thinking of is just wanting something kind of like that. Here, let me get my volume a little adjusted. Okay, so now you can see that it's like, yeah, I wasn't thinking about the fact that doing exponential does something more complicated to the sine wave, right? In terms of the frequency decomposition. Meanwhile, really what I really wanted to do for the spotlight effect is to just do amplitude modulation, which is you just multiply them. And, okay, so that's kind of cool. Now, what's also cool is that, let me see. Is that we should also be able to do things like, have the, well, heck, let's keep in our amplitude modulation too. And so what should happen here is that we're going to have the frequency be changing over time according to a sawtooth wave. So we should be able to it's cool that you can do it like that. We can just sort of add frequencies together and overlap them, and we can literally just add frequencies together. Great, like that's legitimately great. It's always fun when you can just like do the sort of math on signals like that. now, what else do I want to try? Let me see. How long have I been going? 15 minutes. Okay. I've been trying to keep these to, like, not really more than 20, because I feel like at 20 it starts to get kind of a little more unwieldy to watch. But, okay, so I want to try a syntactic thing, which is, I think this works. So if I do one, two, four, I think, I don't know, I think this might do what we want and still give me like multiple sine waves. We're going to find out. Oh wow, no, not even. Oh, you have to multiply. Because, yeah, that definitely did not sound like... do the 1, 2, 4. That could prove useful. I'm not sure for what yet. What else do I want to do? Oh, right. We can, we can, let me see, what do I want? We can do what we were trying to talk about last time of, having things like, you know, making things like a circle be, see. Oh. Made it too big. Yeah, okay. So now we get that iris effect ranging from... Okay. Then, can also... to like... low... So it's so what we're going to see here is if I play some other sound like here, let's do something a little weird. amplitude modulation. Okay, you can see it wiggle a bit more. Here, let's make the quaver. Okay, so we can at least see how that's working, even if there's only so much range you can get out of a single sine wave. Let's see, what else do I want to do? Let's try this quick, even though this is kind of silly. Which is HSV. So I think the idea is that it's going to convert. It's going to take this graph, and that's going to take every pixel which has its 3 channels, and it's going to reinterpret it. Okay, yep, that does work. Very good. There's also another interesting example, which says you use fit to change the aspect ratio. So let's try that. Okay, yeah, that actually does work. It'll be more obvious if I get rid of a lot of this goofiness and just say moth. Okay. Yeah. All right. Yeah, that does in fact kind of correct the aspect ratio a bit. Very cool. Let's multiply the moth by itself. Okay. And so okay, let's be dumb, because I would actually have good intuition for how the graph stuff works here. Okay, that does seem to invert the colors. And if I just did this, I'm pretty sure it would actually just be a proper color inversion. Multiply an image by 1 minus itself seems to actually give something a little more balanced, but still kind of cool looking. What else can we do? Oh, right, there's move functions now. And if we did let's be weird. Woof. Okay. Meanwhile, if we just do this, okay. If I say 0, then okay, then it's just going to move in the x direction. Okay. So if I say 0, but then I also say f of x, should create kind of a weird smearing skew. Cool. If I put 0, 0, yeah, it's the identity. Okay. Yeah. Right. Yep. And we can create like weird smearing effects. Okay, there is something kind of cool happening there. That's actually kind of neat. Very weird, but kind of neat. Yeah, that's what I thought. Let me see. Oh, right, tiling also is a thing. Let's see what happens before we quit. Let's do tile 3, 3. Okay, that sort of works the way you would expect. Now what happens if, so since everything is a graph, is the data type, technically you can just kind of put anything in other arguments. So, yeah, I wouldn't even know. I don't even know what that means. I'm not even sure what I just did. I think I told it. I practically feel like I told it to tile in a pattern that means that it just kind of recreated the original shape. I'm not super sure. But I think that may be what's happened here. Whatever it is, it's kind of a fun kind of freaky. What happens if we do that? Yeah, get weird distortions. What happens if we do this? Oh, neat. Oh, wait. That's actually cool. That's awesome. Wait, no, that's good. Oh, crap. Oh, crap. That's actually cool. Because look at the way it's, like, distorting. And then if we do that in the other direction, but let's do it in different. Okay, that's actually very cool. I'm gonna make this slightly smaller though. 10, 2, okay. Cool. I actually almost like it better when it's just doing it in like that, because then it's yeah, you've got this weird curl that's kind of cool. Here, let's see if I can exaggerate it. And, oh, to the third, so that it's keeping the... Oh, okay, awesome. Yeah, that's actually really fun in ways I wasn't expecting. Yeah, that's cool. I feel like I have a lot more that I want to figure out, but I've actually gone for a half hour now because I got sort of distracted near the end there. So I will go ahead and end things here, and hopefully see you in tomorrow's video.